Hello everyone, welcome to this video. In this video we shall see question from June 2018 consisting of 4.75 marks. The question says, if fx be a given monic polynomial whose coefficients belong to z, the set of integers, right, then the roots of f, they are asking whether they can belong to z or to r minus q union with z or to c minus q union with z or to q minus z, right? So among these four, the roots are the roots belong to which of these, right? So now we are given some polynomial. Say this is the given polynomial f is equal to a0 plus a1x plus up to anxn, right? Where these coefficients ai belongs to z. This is given to us, and also we are given that an is equal to 1. Right, because the polynomial is a monic polynomial, the leading coefficient is 1. So now they are asking, can the root they belong to the set of integers? Yes, the answer to this question is yes, because there are polynomials of this form, x square minus 3x plus 2, right? This is equal to 0. So now you can factorize this. So you'll see that 2 and 2 and 1, they are the root of this polynomial. So x minus 1 and x minus 2. So x is equal to 1 and 2. Therefore, the roots of this polynomial, they belong to the set of integers. Therefore, there are polynomials whose roots belongs to the set of integers. Therefore, this option is correct, right? So now they are asking, the roots of this polynomial, they always belong to r minus q oblique union with z. What does this mean? It means that we have a set of real numbers, and in this we have the set of this is the set of real numbers, and we have the set of rationals, right? And here we have the set of integers, right? So now they are asking r minus q. R minus q is basically this set. So and this set has been union with this small set z, this one, right? The set of integers. So now they are saying this along with this thing, whether our roots always belong to this set or not. For that we need to tell, if we found a root which belongs to the set of rationals, then that would be a contradiction to this thing, always belong to r minus q union with z. So that means we shall go and look for an example of a polynomial, right, such that the polynomial should be monic, should have coefficients in z, and whose root is a rational number. So can we find any polynomial of that kind? Actually, you can see this using this result. This result is rational root theorem, which says that if you are given any polynomial of this kind, a0 plus a1x plus up to anx raised to power n, whose coefficients are integers, and these two terms, the constant term and the leading coefficients, they are non-zero. So then we have a rational root if these conditions are satisfied. What are the conditions? That the numerator p, it should divide the constant term over here, and the denominator, that is q, it should divide the leading coefficient over here. But in our question we are given an to be 1, right? So p divides a0. This is one thing. We do not know as such a0. A0 could be any number, but a1 is given to us. So q divides a1. It implies that q should be equal to 1. Therefore, our root, the rational root, it would be x is equal to p upon 1 kind. So that means we only have roots of this kind. So these could either be integers, right, or they could either be some rational numbers, not rational but irrational numbers, right? Or they could be complex number also. How this is so? Suppose this thing is clear, there is no doubt. Suppose we have a polynomial of this kind, x square minus 5 is equal to 0. Now this polynomial has all the coefficients in integers, has the leading coefficient 1, that is it is monic. So now we need to its root. What are its root? Its roots are plus minus square root of 5. So now this thing, these are irrational, so it belongs to r minus q, right? And for complex roots, we can have this equation, x square plus 1 is equal to 0. Now this polynomial, it is a monic polynomial having coefficients in integers, right? But its root, they are plus minus iota, so they are complex numbers, so its root belong to set of complex numbers. So they are saying, in second option, they are saying our roots of polynomial of this kind, they always belong to such set. So they are integers, yes, they are integers. They belongs to r minus q, that means they belongs to the set of irrational numbers, yes, right? But we have a polynomial x square plus 1 and many more of this kind whose roots are complex numbers, so they do not belong to this complete set. Therefore this option is incorrect. Let us see third option. In third option, they are saying the roots could be integers. Yes, it is true. The roots could belong to c minus q. Now c minus q, what kind of set is this? This is our c. It has real numbers, right? Then it has q and then it has z, right? So now they are saying they have subtracted this q from c, right? So they have subtracted this q from c and they have kept this z. So we have this z and we have this whole thing except q. So we have z, the roots belongs to z, yes. It also belongs to irrational numbers, yes. And it also belongs to set of complex numbers, right? Except rationals. Therefore this option is correct. Now coming to option number 4th, they say the roots can belong to q minus z. So fourth option, as I have already discussed, has been discarded from the list. Why? Because the set q minus z do not have integers within it, right? And the only roots of this kind for a monic polynomial, they are integers only. Therefore this option is incorrect. So option D is incorrect. So the only correct options are option A and option C. Well, that is it for this video. Thank you for watching.